There's a Discovery sitting on the launch pad. We hope to see that quite frequently in the next few years. We had a hard time getting Jim Bajan to wear a coat and tie, and our last chance was launch morning, so we all got dressed up, and he finally agreed to do that. So we wore coats and ties. And here we are in the suit room, getting those launch and entry suits on. If they look uncomfortable, that's because they are. And we're walking out of the crew quarters into the astronaut van, looking like 5 orange doughboys here. If we ever end up in the water, we'll be glad we have those suits on, but they sure are uncomfortable to wear, especially if you're used to the old flight suits that we wore for so many years. Of course, as most of you realize, we had a couple-hour launch delay waiting for the fog to burn off and the upper-level winds to exceedances to go away. So we were really pleased when they started the countdown out of the 9-minute hole. After 4 hours on our back, it was a relief to start counting down again and realize we're going to go fly. Turned out to be a beautiful day once the fog had burned off. One of the things we did during this flight was activate a camera to record any debris striking the windows during the first couple minutes while the solid rocket boosters are firing. The camera was on John's side over there, and we got down to 10 seconds before liftoff, and all 5 of us in unison said, "Get the camera, John." Wouldn't let him forget that. And of course, after 2 minutes, the solid rocket boosters come off, and that's always a good feeling. Now here we have a shot of the Indian Ocean, the southern tip of India with the island of Sri Lanka. Used to be Ceylon, called Ceylon down there. I think that's a beautiful shot.
Once we got past the launch and fully into the orbit phase, we started reconfiguring the cockpit to try and get things ready for the IUS deploy. I think one of the more difficult things about this particular mission is the post-insertion timeline and getting ready for the deploy operations. You've got to configure from your launch configuration, reconfigure the entire orbiter for the deploy operations, for the on-orbit operations. We facilitated this to some extent as soon as we got on orbit by going ahead, getting out of the launch entry suits and getting into our more comfortable on-orbit clothing, which you can see varied somewhat, getting ready for the TDRS and IUS deploy. Once we got everything started, 6 hours and 12 minutes into the mission, we went ahead and deployed the IUS TDRS. It was a successful deploy. We had hearts almost stopped about 2 minutes before deploy. We got a series of anomalies and warnings that looked like everything had failed. And it turns out it was just a data drop on the communication link between the IUS and the orbiter. We got a quick go for the deploy from the ground when they saw that their telemetry was all right, so we proceeded with the deploy and got it off on time. We were very delighted shortly thereafter. Had the 2 burns that it took to get the IUS up to its geosynchronous orbit, and we found out that those 2 burns went on schedule and as programmed. TDRS was put into its initial orbit. I think it initially had a 40 foot per second underspeed as far as getting to its geosynchronous altitude, but as it turns out that was not all bad. It was a slight underburn, and it was on the right side of things as the orbital mechanics of it go, and it was actually started to drift already toward its park orbit. Right after we got done with the TDRS deploy, I had to get into an experiment activation. This is the protein crystal growth experiment. Fascinating experiment because it's one of the things we've learned to do in the microgravity environment of space is to be able to grow crystals, in this case protein crystals, that are used in a variety of applications in pharmacology. From our standpoint on the orbiter, our biggest job after activating the experiment, going ahead and mixing the ingredients, the precipitates that would help to form the crystals, was to do some photography of it. We did an activation photography to capture what the experiment looked like as we started up.
This is the Chromex experiment. It's a plant growth experiment we flew to see how plant roots that would just start to germinate would develop on orbit without the influence of gravity. And that way to see if the chromosome divisions that normally take place would proceed as you'd expect and allow the growth of the plant. This is particularly useful for future ops in space station, where people worry about both for food growth and closed environmental control systems, where you can not only scrub CO2 but generate some oxygen. This is one of the life sciences experiments. It's a transcranial Doppler. It's one of the DSOs. And here we're looking at some blood flow in the middle cerebral artery, and that's the velocity waveform, looking there on Mike. And we hope to try to correlate changes in blood flow in the brain with possible symptoms of space adaptation syndrome, and in that way maybe get a little bit better handle on what the cause. So we did a fair amount of studies on that to try to get that wrapped up. Here's a little thing we did on the side. There was concerns for space station about how to, since we'll be there for a longer period of time, how to deliver normal type health care, how to care for people. And this is an IV bag, intravenous fluid. You have bubbles in it. Well, on Earth, they just drift to the top and you get them out. In zero-G, they just kind of look like effervescence, just bubbles suspended in the fluid. Well, by just centrifuging it by hand like that, you're able to have all the bubbles migrate to the one end and just bleed it right off without any extra equipment on board. Just use a blood pressure cuff in the IV bag, just as you would here on Earth. So it works real well. Here's Bob doing a central venous pressure measurement, and by blowing in that mouthpiece, he raises his pressure in his lungs to the same pressure as the central venous pressure, and then when that happens, there's no longer any flow, and he was measuring the flow in the external jugular vein there with the flow probe. Also, we thought that there was a study to look at changes in intraocular pressure. Just as you measure intraocular pressure for glaucoma, we're using what's called a tono pen. And here you have to anesthetize your cornea, which I just did with those little drops. And now I shove this pen and tap it off my cornea and continue to tap it. And you got to get used to that, just staring in the eye as you bounce it off your cornea. You can tell when you touch it, not because you feel it, but it changes your refractive error. You can see the thing get blurry.
This is John Vellinger's experiment. You know, he's a senior up at Purdue University now. He started this experiment many years ago. He really did a great job with this. I really congratulate him. We saw him last Friday. He told us preliminary results so far. As it turns out, the embryos that launched that were 2 days old had died on landing for some reason up in orbit, and they have to figure that out yet. Also, on Easter Saturday, all 16 of 16 that launched that were 9 days old hatched. So maybe some very significant results and a lot of unanswered questions from that experiment.
This is another thing for space station we were looking at. They were concerned, could you use standard type medical equipment like for suturing wounds, stitching up wounds as you would in 1G. So we just had a little block with some basically like artificial skin with various lacerations made in it, since they didn't want us to lacerate ourselves. Plus it's a little tougher to get volunteers for that. It would have been a first though. Anyway, we got the suture material out and just to see if you could stitch up a wound in the same way you would here on Earth. And Bob did a good job focusing on the suture. You can see it right there. It doesn't tangle up. The normal lengths like you use in the operating room here will work there. It works just fine.
What you see on the longeron here is a SHARE experiment, which is a space station radiator assembly. Though it didn't perform as we had predicted, the NASA engineers and mission control team were able to get an awful lot of very, very good data from this experiment. And it really tells us why it's so important to fly pieces of the space station and equipment on early shuttle flights so we can get a good engineering basis for station. Here we are in the mid-deck. Mike's looking at a TAGS picture. TAGS is text and graphics, which allows us to send up high-fidelity, almost like thermograph type pictures. We use these during our IMAX filming to look ahead at weather satellite photographs so we could tell what areas were going to be clear around the world and which were not. On the flight deck, we did several experiments. This one happens to be which is an optical device allowing the crew to realign their inertial platforms in the event that they should malfunction and lose their nav base. Mike was able to do that sighting on the sun.
This is the IMAX camera, and you see Jim here loading the magazine, putting the film into the camera. I might compliment the IMAX people. Excellent support and training they gave us throughout the lead up to the mission, which really enabled us to be very successful. We found operating with the camera in 0G to be quite similar to 1G and had no difficulty loading the film. Here's a scene on the flight deck. Jim's holding the camera here, and I'm trying to put a 100mm lens on in this case. And you see Mike up front talking to mission control. This is usually the sequence. Mike was trying to maneuver the orbiter. Here's a shot of me taking a picture, of this case, Florida, and coming into the Bahamas here, I believe. But basically, the way we worked with IMAX is we had somebody filming, we had somebody as a spotter looking out the window, because when you look through the viewfinder of the IMAX, it really shrinks your field of view. And so you need a spotter and somebody maneuvering the orbiter. And of course, Jim was working, changing out the magazines in the black bag usually, and I was loading the camera. So quite a team effort to pull off the filming we did for IMAX.
Some of the other cameras we had on board that we used for Earth observations are 70mm Hasselblad. This happens to be a shot over Cuba. Of note is all of the active coral reefs just at the south side of Cuba. We added some very, very good shots of that and showed some live coral and reef formation just south of that island. As you can see, the whole East Coast was very clear for most of our mission, including the Caribbean, so we got some footage that normally is cloud covered. Another camera that we used extensively was the Aero Linhof. It's a handheld aerial photography camera, a little bit larger film format, and as a result the resolution is somewhat better than some of the smaller film cameras. This shot is coming over Central America, looking down a chain of volcanoes. You can see the volcano sticking up in the lake. And again, John using another Hasselblad camera. We were able to use, with the attitude we were in, use just about all of the windows. The side windows for oblique shots, overhead windows for directly down, and it worked out very, very well for our Earth observation program.
Trouble is, we had 4 good windows and 5 crewmen.
This is a shot of the Himalayas. It shows a view looking north. You can see the orbiter tail at the top. And the brownish area in the background is the Tibetan Plateau, and it gives you a nice feel for it. In the north-looking view, you see it more in profile, and it really gives you a feeling of the relief, the elevation of the Himalayas there, because in the foreground, the Ganges River Basin is basically sea level, so you're seeing a 29,000-foot rise down to a 13,000-foot plateau behind. And it's even more impressive in person.
That's the problem of having your satellite deploy on the first day, is that after that somebody has to get stuck with the housekeeping chores. So here's a shot of the food preparation process. Actually, what I would note is that number one, the galley worked very, very well for us. Since this was my first flight, I was very pleasantly surprised at how palatable the food was. The cold water was cold, the hot water was hot, just the way it's supposed to be, and that was actually a bit of a surprise. We actually have an oven on board that we can use to heat up the food. And it's a bit like a camping trip in a way that there's a lot of overhead that goes into maintaining the shuttle, and the food preparation is part of it. We did finally get together for a crew dinner, although that was a rarity actually on this flight. We stayed busy enough that for most of the meals we just worked right through the meal, and somebody that was available would do the food prep down on the middeck, and then as you had a couple minutes you'd float by and grab something and have your dinner on the run, so to speak, or on the fly, I guess is more appropriate. But we did sit down, I think on the 4th night or 5th night, and have a dinner all together, and it was the one family meal that we had on board the shuttle on this particular flight.
We wanted a shot of the sleeping bags. You can see I'm getting into one sleeping bag and Jim Buckley's getting into the other. He's more or less heads down and I'm somewhat heads up here. You can obviously sleep any way you want up there. You don't need to sleep in a sleeping bag. I like it because it keeps the temperature pretty constant. It keeps you from floating off and bumping into things in the middle of the night. And I found that very comfortable just to put a sleeping bag up against the lockers, and gave me a little bit of stability.
This is Jim and Bob. Actually, one time I came into the middeck and I saw them doing this, so I grabbed the 16 millimeter and started taking this footage. I couldn't figure out what was quite going on here. Here we had a doctor and a Marine trying to prove who could do the most pull-ups, so I couldn't resist the picture.
Marine won.
The next time I came through the middeck, Jim happened to have this set up, our treadmill, so I jumped on there. They looked like they were doing real good. I thought I'd try it, and unfortunately, that was a lot tougher than I thought it was.
Well, despite the fact that we were working very hard, there's always the ever-present fluid experiments that we wanted to do. And while on one hand it's a bit of fun doing this, it's also very useful when we're talking to school children. It allows you to see what happens to a fluid when it's released in the microgravity of space, and of course a fluid will tend to assume its minimal energy level, which is a sphere. And that's the science part of it. The fun part of it is watching a bunch of grown men trying to play with bubbles of fluid in zero gravity.
We tried very hard to get two two spheres to float together to see what they do. That may be impossible. We couldn't do it in an hour or so of trying.
This is actually remarkable. This is a remarkable shot because we had. This was just the morning before our press conference on board the shuttle, and we had all changed into clean clothes. Mike had gotten cleaned up, put on a clean white shirt, and then proceeded to play with drops of strawberry juice, which he managed to splatter across his white shirt just before the press conference.
Well, this tells the truth. We said we wanted to fly tortillas, and we're more interested in that than fresh bread, but I think it was probably more for the aerodynamic qualities of the tortillas than their actual flavor.
Interestingly enough, though, that proved the tortillas proved to be a very good bread substitute. Didn't crumble as much.
The suits we normally stored in the airlock, except when we first got on orbit. When you're not in them, there's no weight. They just kind of take on a life of their own, and they take up a lot of room. Here we are, just kind of playing around the night before. We pulled the suits out to check them out to make sure everything was set up the way we thought they should be, and if there's any servicing they needed, we could do that. And it just shows, there's only 2 or 3 suits in the picture, and there's actually 5 of them there. It takes a lot of room. Here's we're just going through a suit donning here. Bob and I, Jim, just helping us a little bit to get in, and you find you can just kind of float and just kind of, with more or less effort, pop on through. I don't have to worry about catching my hair on the neck seal when I come through, so it's probably a little easier for me in that respect. But they're fairly quick donning. The biggest trouble is getting the zipper. You have to pull around, and you always can. Most of us need a hand. All of us don't. I certainly do.
It's the shot of a sunset again. We really enjoyed the sunsets and sunrises, as you've always heard. Whenever we have a cloud mass sticking up into the atmosphere, it's a beautiful sight. This is a shot during reentry taken from Vandenberg Air Force Base. They tell us this is about 150,000 feet up, so that's quite a camera they've got down there. Here we are coming down the outer glide slope, getting ready to land on the runway, Edwards 22. We do so much training in the shuttle training airplane that once you get down below about 15,000 feet, you feel like you've been there 100 times before. It's a very comfortable situation. The only difference is the wind noise. Of course, in the shuttle training airplane, you have the engines running all the time, even in reverse, and it's a little bit noisy, and you don't have that, of course, with a shuttle. So you can hear the wind noise. We're very interested in doing a braking evaluation, which is why we landed on the runway. And we wanted to follow our normal braking profile and put about 25 million foot-pounds into each of the main gear brakes. And we hit that very close. I think we had 22 million in the left side and 29 million foot-pounds in the right side. So it was a very successful test, and it responded quite well. We were very pleased with the brakes. Since it was so cool outside, about 40 degrees, we elected to keep the launch and entry suits on instead of trying to struggle out of them down in the middeck after we landed. It's really crew preference what they want to do when they get on the ground.